So who am I? I'm Chris. I founded a studio called KAR Games. We're a Godot-focused studio from Cincinnati, Ohio. We did not make Dome Keeper. We actually started off with a game called Drift Space Survival. It's been in early access since about 2023. It's a 3D open world survival crafting game in space. Multiplayer drop in, drop out, and so I got to learn all the hard things during that process. But that allowed us to really learn like how these networked game systems work, how you actually want to talk from client to client, and specifically in Godot, how to take advantage of the systems there. So I spent a lot of time thinking about network game systems, and I spend even more time covered in children. So I actually think of myself first as a dad, then a game dev, and then everything else in life. So a lot of you guys know Dome Keeper. Dome Keeper has been a huge supporter of Godot. Actually, when you launch a game, the splash screen just has the Godot logo just all over it. They built this game in Ludum Dare. Built it in 72 hours. At the time, it was called Dome Romantic. That version is actually still on itch. You can go back and play to see where they started. In Dome Keeper, you defend yourself against waves of monsters. You dig down into the mine, find resources, use those resources to upgrade your dome, and survive. Since they launched the first version in 2022 on Steam, they've added 10 big content updates, adding new keepers, new domes, new game modes. And the game has gotten massive. When we actually started the multiplayer port in November, there's 62,000 lines of GDScript. I found that out after I agreed to port it to multiplayer, but it's fine. And of course, when you ask players, they just want you to add multiplayer. Just click the button, whatever that makes it multiplayer, and everyone will be happy. For fun, I went into their Discord and searched for the words multiplayer and co-op, and just found just hundreds and thousands of different messages about people wondering when this is going to happen. My favorite really just comes down to multiplayer when. You know, like, come on, guys, like, what are you doing? It just can't be that hard. And even the developers of Dome Keeper at Bip and Bits, back even before the first Steam release, were playing with local co-op and realized that this is a perfect fit for this type of game. But getting it right, even locally, can be really difficult. And so this has been an ongoing project. You can see the roots of it inside the code. You know, a lot of people, when they're making mods for Dome Keeper, they can just decompile it down to the code, and you can see the parts where they've thought about this, but it's never been something that's been officially released. So I want to talk about kind of where we started when we started this process, and maybe how you can also go through this process with your existing single-player game. Multiplayer is a really loaded term. It means a lot of things. You can have multiplayer just because you can pick up the second controller and control one part of it, or you can have, you know, full Call of Duty online matchmaking, you know, rank system and things like that. So some things to think about: is this local multiplayer or is it online multiplayer? Is this competitive? Are you actually competing against people? Is there prestige? Is there anything like that, or is this just a friendly match between people? How many players? Sometimes you just want to add a second player, and that can be different than making it 8 players or 64 players. If we decide to do online, is it public? Am I playing with the whole world, or is I have to find a friend and coordinate outside of the game? Are we playing the single player game, but with multiple people, or is this a special multiplayer mode? And can a player join mid-match? This is actually something that can be really difficult to add after the fact. Just in the same way it's difficult to move from single player to multiplayer, adding mid-join is something you have to think about up front. So when you're thinking about local or online, one thing to note is local is actually orders of magnitude easier to develop. When you work with an online multiplayer world, you actually have 2 clients running your exe that have no idea about each other than the data that you send back and forth. Where if you're having local multiplayer, you have all the data that you currently have in your single player game. Now you can do local multiplayer and then add Steam Remote Play, and then people can on Steam play with each other online. However, there's no equivalent of that for consoles, and because of that, there's no equivalent for crossplay if you decide that's important to you. If you decide for online multiplayer, it actually kind of eliminates couch co-op, which is a huge motivation for the Bip and Bits team. Renee and Anna both love to sit down and play games together, and they'd love to play their own game together. But in theory, it is possible to mix both if you make that decision up front. Competitive or friendly? This is actually the most important question that you should be asking yourself about the multiplayer experience that you're trying to develop. Because it all comes down to, can we actually trust the packets that you get from the other client? If you are creating a competitive game, you don't want cheaters. It's just not fun. And people will be able to cheat if all they have to do is change their local game state and send it over to you. And if you do want to verify those packets, you actually need servers running the game because you as the host could cheat yourself. So it's really like, are we trying to create a competitive experience that is fair? Or are we just, this is a friendly match, and if you have friends who cheat, then you have terrible friends. So speaking of friends, how many players are we going to actually have? So this all really thinks about how you're changing the data structures in your game. Are you going to go from one to many, so you can have 2, 3, 4 players? Because sometimes you just want to add that second player. It's just a purely co-op experience. And even though it might not feel great, you could just add a player and a player 2 variable in these data structures and think about it that way. Especially if you're, again, adapting an existing game, you might want to do things differently than if you're designing a multiplayer experience from the ground up. Sometimes some games have these little sibling modes, so you just hand your little brother the other controller and have them control the gun while you get to run around or drive the tank or whatnot. Or it was just a full multiplayer experience. And then one thing to think about with the number of players, most games these days are more peer-to-peer. Again, we don't have run servers up in the cloud. And so if you are the host and you have to send all this data to one friend, it's linearly going to expand how many people you have to send to. So if you have anything that's bandwidth intensive, that can limit the number of players you have. So if you decide to go online, are we doing these public lobbies or do you want to invite a friend? It really comes down to, do I have to deal with jerks on the internet or just my jerk friends? One thing we found and talked about a lot is public lobbies, if you have any sort of versus mode, all of a sudden will create this perception of competitive. Even if you made that decision earlier that we're going to trust packets and things like that, when you don't know the person on the other side, it can just create a bad experience. But without public lobbies, enabling crossplay can be difficult as you start to think about how are we connecting if I'm on Steam and I can't just right-click invite you from a console. Thinking about game modes. So do we just want to allow players in the existing game modes and just bring as many as you want, or do we want to limit it to certain game modes? Are you creating a new game mode for multiplayer? Is the multiplayer version of your game different? I always think about Mass Effect 3, it was a very single player game, but they had that whole multiplayer game mode. And if you did well, you could take those points back into your single player experience. And are the rules different when there are more players present? So is the game getting harder? Does the game have built-in systems that kind of make it inherently harder? So for Dumbkeeper, if you have more people but the same number of resources and everyone needs to buy their own upgrades, you actually have a built-in kind of sunk cost there. And so it actually can get harder with more people. And so finding that balance can be difficult. And the last one is joining mid-match. Like I said, this can really be difficult if you don't do it up front. So if a friend's already playing online and I want to hop back in, or unfortunately you drop out because of network lag or anything like that and you want to get back in, can you let that player back into the game? Can we find a way to get that client to catch up, get to the state? What we found for Dumbkeeper specifically is this is actually a more of an issue during combat than the mining phase. So getting the tile data and everything was right, but getting those monsters kind of perfectly in sync ends up being really difficult without being incredibly bandwidth unfriendly. So one thing we thought about is, can we do this during the mining phase, but if you're in the combat phase, then you kind of might wait in the lobby. So looking back at our 6 questions we asked, this is kind of where we ended up for Dumbkeeper multiplayer. So local or online, we decided to go with both. We made that decision up front. So If you have 2 or 3 players on your local client, more likely on a console than on PC, when you join someone, they all come with you. Is it competitive or friendly? We're decidedly in the friendly camp. We're not interested in making this crazy competitive game. And I actually don't know that I think it could be possible or make financial sense to run these fleet of servers to keep these going for a game like Dome Keeper. How many players? This one is interesting. We originally decided just 2 for co-op, and if you decided to do a versus mode, you can bring a friend for each side. You could do 4. But while we were playtesting, one of the times we had 7 or 8 people who were able to jump on the playtest, so we decided to just open it up, just see how it was. And it was absolutely chaotic, but like in the best way, it just made us revisit the whole decision. We're like, well, maybe, so it's like if we could just do a few things. So we're gonna kind of leave that upper end open, but you probably need a really good internet connection, powerful computer to be able to handle like 8 people bringing a bunch of different resources back to the dome. Public or invite, we went invite for the same reason. We just want to avoid any sort of perception of competitiveness. They have a really active community on Discord. You can go there if you don't have someone to play with and kind of coordinate there. We decided to do all existing game modes. You can bring a friend. And then we're actually building a separate versus mode where you have 2 domes and you can both have the shared mine. And so you're competing for resources and some exciting things I think that Renee at Bip and Bits is working on that I think he's going to share with the community soon. And then can a player join mid-match? Yep, but just not during battle. This might be something that changes before release as we play test this further. It's possible that it creates more problems, and so it might be something, probably the first thing to get cut as it creates additional issues. So how did it go? So it took about 3 months to get to the play test, like full kind of game loop play test with limited content. Our first ever play test, we had 7 people, and like I mentioned, it just was like absolute chaos. We had no idea what was happening. My favorite thing is we're all in voice chat, and there's 7 of us in the game. We just assumed someone was going to be up in the dome fighting monsters. We lost both times because it was just like, because we have 2 weapons, 7 people. Surely someone will be up there helping out. But it was just so much fun. It required a lot of coordination in voice, and I actually took most of these videos from bugs that are reported, so you might be able to see some of the issues happening here. So what are the challenges that we faced? A lot of them, but the ones that I tried to think about, ones that again might apply to you and your journey going down the multiplayer path, and specifically single player to multiplayer. Again, if you were to build a multiplayer game from scratch, I might have different advice for you. So system architecture, how are we getting the right data to all the clients at the right time without rewriting all 62,000 lines of GDScript? Bandwidth optimization, what is that minimum amount of data that we can send to stay in sync? The lower the bandwidth, the more players we can support, and the less chance of just creating a bunch of laggy things going on there. And we knew out the gate we wanted to support crossplay, we wanted to support local network, we wanted to support Steam. So how do we avoid writing a lot of this code 3 times? And then again, this is for porting existing game, so don't take this as gospel for writing a new multiplayer game out the gate. So system architecture, there's one thing that I think is really difficult about moving code that works in single player to multiplayer is that you assume so many things about what data you have available to your function or to that logic. And so if you assume you have all the data when you need it, you don't have the defensiveness that you need in a multiplayer game of one example is just even simple, like when I load the level, the camera should focus on the keeper. Well, if you're a client, you actually load the level before the keepers come in, so you actually don't have a keeper, and we don't know where to put the camera, and it can crash the game. Or sometimes the keeper does get there, the packet for the keeper gets there before the level's done loading, so you have it, so it works 50% of the time. And these are the type of issues that just permeate every system in your game because you're just so used to having every bit of data available to you. In addition, one thing that can be really difficult is a client connects to you, and Godot sees that connection, and then Godot wants to then send all the data to that new client. So especially if you're joining mid-game, but even if you're just trying to join during the lobby, it assumes that once you connect, you're ready for all this data. And that we found that there's a lot of reasons that that doesn't work in Dome Keeper. And so you get all these errors about data coming in that it's not ready for. It doesn't have the node available for that. Or you still might be parsing the map data and trying to build the map on a slower computer, but the host has already moved into the level stage and is trying to send you, oh, here's where my keeper's position is, and I just broke this tile. But you're still in the loading phase. And so again, you're getting a lot of data that you don't know what to do with, and you don't know how to catch up once you get in there. So there's two approaches that you can take. One that I think is probably maybe what happened in the multiplayer workshop and what you see in a lot of tutorials is make sure that everyone is in the same phase when you're joining and connecting. It's just a lobby phase. You're just exchanging as little data as possible during that time. And then everyone moves into the game scene, gets everything set up, and then they rely on these kind of like reliable ordered packets just to make sure that everyone's following the same kind of like path to get there. But we found even with that, you still might, again, if someone's computer's faster, they may be done loading and start sending packets before you're ready. You're getting tons of errors in your log that are pretty unactionable. They're just like data that you're not ready for. And so the other option is you basically have each client maintain its local connection state and say, I'm in the lobby phase, or I'm in the loading phase, or I'm in the spawn phase. And you tell everyone about that, but then you have to have every RPC call in your game look at that to see who they're actually sending those packets to. So it's a ton more boilerplate, but it does allow you to have a little bit more flexibility on when you actually send that data. So one thing I should note is when you send in a remote procedural call, an RPC in Godot, through the node system, the client has to have a node, not the same node, a node with the exact same RPC function name and function arguments on the other side. Most of the time this will be the same node, but there's some cases where you might want that to be a little bit different. But it has to exist when that packet comes or you're going to get a lot of errors. You can avoid these errors by sending everything through like singletons and global nodes, but you're kind of just ignoring the issue that you have a client who's connected, who's getting data that they don't know what to do with. So what we do is we have this kind of enum connection state around what stage of loading the game that they're in. And so they can basically tell everyone where I'm at and what packets they're ready to receive. And one thing I should note is these kind of spawn connection states are interesting. So if you have something that has a dynamic number of nodes, so like a keeper, like we might have 2 keepers or 4 keepers, and we won't know until we actually get all the keepers in that we have it. We have this kind of intermediate connection state so that you get all the keepers in, you announce that you have all the keepers, and then all the keepers can start sending you their positional data. So why do we use RPCs? So there's additional nodes that you can use in Godot, like the multiplayer synchronizer, the multiplayer spawner. And we almost always started with those nodes. But over time, we've transitioned everything out of those because we really wanted to have control of when those first packets are sent based on the connection state. So the built-in multiplayer synchronizer, we could have used to have a built-in visibility functionality. We could have used that in connection with our connection state. To do that, but something like the spawner is really greedy. It just wants to, like, as soon as that other client is connected, it wants to get everything in sync. And if you miss that first packet on the spawner, it won't be able to catch up. And so we decided to do something a little bit more manual, but it allowed us to, again, maintain that, like, what is that first packet? When does it get sent? Are they really ready for this? And I think that gives us a lot more stability in the process. So we wrote our own synchronizer. That synchronizer, as you can imagine, takes in connection states. It will look through every client that's connected, so we're peer-to-peer, so everyone's talking to everyone else. And as long as they're in the right connection state, we'll send them the packet when they're ready for it. The synchronizer actually distinguishes what that first packet is. So similar to a spawner, that spawn packet, we can send in, hey, here's everything you need to know to get started. And then here's everything. That's how it changes on each network tick. We still use the multiplayer authority system. I think that's something that really trips up a lot of people. When you have multiplayer authority in Godot, it says who is allowed to send this packet to other people. And so by default, it's always the host is allowed to send you packets. You're not allowed to send them other packets. But you can mark RPCs that, hey, I'll accept this from anyone. But what we actually do is we give keepers. So if you're a client and you're controlling your keeper, you're the authority of where you are. And so everyone, when that keeper spawns, says, okay, who's controlling this? Well, they're the authority themselves. But we also use it for things like weapons and laser, like you're controlling the laser on the dome. You're in control of that. You're the one sending input. So rather than having that input lag of going to the host and back, you get to control it and tell everyone else where it is. But again, we only get to do that because we're friendly. We're invite-only lobbies. You don't have people trying to mess with you. So sending all these RPCs, how do you think about bandwidth? How do you know what to send to keep these systems in sync? And so I always talk about trying to get down to the primitives of what is again, how do you represent a system in your game that you can save down to a few like dictionaries, integers, floats, whatever it is, and then bring back into the game and represent it the same way. We actually found that this is really easy with an existing like finished single player game because it actually has saves. Like you can save your game, you can load your game. Well, you've done all the hard work of how do you like save down to these primitives and bring back this this game state. And so you can take these serialized functions and run them through var to bytes, and now you have serialized data to send over the network. Again, it's not very bandwidth efficient, but a lot of times if you're just trying to get that first packet in, and especially if you're early in the process of converting your game to multiplayer, just using that save system and just like basically loading saves all the time on the other client can get you pretty far. And so you already have these deserialized functions, just load it on the client and keep it up. Now, when you have that initial save and you have that initial state, now you need to keep up. So what's happening from frame to frame that's going to change the game and change the game state? So you could just send new state changes after each change or every frame, depending on the game system. You can send an RPC just as an event-driven, hey, this happened, you need to represent this on every client. Or the systems are deterministic and stay in sync from the get-go. And more likely, all of the above. So state synchronization is kind of the formal term for a pretty common technique in games, which is kind of what I described. You take the state, you serialize it down to the primitives, you send it over the network, and they recreate the state based on that. It's actually required for anything that's non-deterministic, like physics in Godot. And so in Domekeeper, when you're carrying all the iron and the water and trying to drag that up, and they're bouncing off each other, they're hitting the walls and spinning, it's basically impossible to get that to be deterministic in Godot in any meaningful way. And so what happens is the host is responsible for all of that and is sending new updated states for all those drops as long as they're changing to every client connected. So this is a balance of bandwidth, interpolation, and prediction. So interpolation is if we don't send it every frame, how does it act in between? Or we drop a packet, how are we acting in between? Prediction, which we actually end up removing after we added it once and removed it because it just got weird, is trying to like where would you think it would go based on its like linear velocity and angular velocity and things like that. But these can actually like make or break a multiplayer experience. So if you think about any like really bad experience you've had in multiplayer, people just are rubber banding back and forth and jumping around. That's when these sort of systems have started to break down, either because of network connection or anything like that. And we send these as unreliable packets, but with a fixed interval. So usually like every physics frame or every other physics frame. So when you're sending something so often, you have to be thoughtful about how much data you're sending. So you probably don't want to do var to bytes on a giant dictionary and get that big byte array back. But Godot ships us something called a packed byte array, and it gives you the tools that you need to create smaller packets. But it requires you to think about offsets. So if you encode like an 8-bit integer, you know that's 1 byte, and so you have to increase your offset by 1. If you encode a float, it's going to be this many bytes, and you have to think about that data. And if you decide to change things, you might have resized the array to the wrong size or did it in the wrong order, things like that. And so it kind of falls apart really quickly. And so one of the things we worked with the team at Bits is kind of creating this packed byte stream, which is a custom class that basically allows you to not have to think about that offset math, but it does require you to think about order. So if you start, from start to end, and you can just call in code. And we added additional support for things like vector 2s and booleans and things like that. And what you can do then is, what we like to do is keep the functions for encoding and decoding right next to each other, so we can just ensure that all the same ordering is happening, but again, it keeps you from having to do a lot of math. Now, sometimes in our specific case for the resources, that wasn't enough. So there's certain things on the resources that were like booleans. And so that's 1 bit of information, but when you encode it into an integer, that's actually turned into 8 bits. So you have just 7 wasted bits for every boolean that you're packing. And so you might want to go from byte packing to bit packing. And this is like the extreme case. So you want to use bitwise operations for bit shifting and XORing and all that's the fun stuff. So you can pack booleans into 1 bytes. You can convert integers to the smallest size that you need. You can convert floats into integer steps and do all that. And using this, we were actually able to save 75% of the bandwidth versus even using the packed byte array. It would be even more ridiculous against like a var to bytes dictionary. But this code is entirely unreadable. Like, I mean, it's just pure nonsense. So it was one of the last things that we did, and it was really inspired by that big playtest we did. We're like, well, 7 and 8 people is actually a lot of fun, but we were sending down like 2 megabytes a second in bandwidth, so like we needed to really pull that back. So that's state synchronization. Event-driven RPCs are really much better when you can make them work. So the game will only change in a deterministic way based on user input. So this is things like hitting the tiles, using gadgets, upgrading your base, using request and response. The client tells the server about it. The server then tells everyone else about it, and everyone's game state can update accordingly. And these are typically reliable packets, as the delivery truly matters and the order matters. And so if you're trying to upgrade multiple things, a lot of times that order is really important. So the third way is you actually have a deterministic game system from the start. And we found that many of the game systems, specifically in Domekeeper, could have been deterministic, but they aren't by default because they might use the system-wide RNG to get like random floats and things like that. And so what we did is every time that we needed random numbers, we would actually try and precede that with something unique to that resource. So for a monster, they all had UIDs on them. We use that as a seed for its own random number generator so that we don't have to be sending down, hey, here are the 10 random numbers we came up with for this monster. It can just decide that on everyone's client themselves. And so by doing things like this and the way that the monsters work in Domekeeper, we actually never have to send like, here's this monster's position. They all can decide it themselves. And again, that just saves so much bandwidth because trying to send positional data for 30, 50 monsters on the screen, especially if 2 domes that you're getting attacked by a final wave, there's no way it probably would have worked. So our last challenge was kind of writing for 3 networks. And so we know we wanted to support all 3 types of networks in the game without writing the code 3 different times. Godot ships with the eNet built in, and they have the eNet multiplayer peer, which handles LAN. Godot Steam, which I know a lot of people use, actually ships a Steam multiplayer peer that I used in my first game, Drift. And so we had 2 out of 3 just by leaning into Godot's high-level networking. So we decided to commit and actually create a custom peer that handles crossplay. And so we actually integrated the PlayFab Party API, created a PlayFab Party multiplayer peer that just is a drop-in replacement for eNet and Steam. So in our code, it's 5 different lines of GDScript that switches from LAN, Steam, and crossplay by again, leaning into that kind of high-level multiplaying framework from Godot. So what are some takeaways from our experience that I think you should take to your project of going from single player to multiplayer? I said it a lot and I'll say it again, not all multiplayer is the same. So those early decisions, whether you're online or local, competitive or co-op, are how you can limit the scope and make this an approachable project for you. Not every game needs that full online matchmaking experience. The dream for a lot of players is I want to play with my friend. And so listen to your community, talk to them about what's important to them, what is the experience that they're actually chasing. and maybe you can ship it to them without going crazy. Speaking of going crazy, it'll never be perfect. One thing that was really enlightening to me when I started working on multiplayer games is I had this expectation that everything would be perfect from client to client. And then I would go play games like Valheim and Minecraft, and then like you're like, oh, like that's not the real, it's just not real. It never happens, even in perfect network conditions. And so 90% of our network updates are just triggering local visuals and sounds. The host is always the source of truth. And so it doesn't really matter if the client knew about this thing happening. We're just trying to like recreate the game state and keep you in the loop about what's happening in the real game. And so because these are just visual updates, it actually doesn't need to be perfect. And so again, using the like the UID as the random seed, you can generate a lot of this visual data. And even if it's like a frame or two off, or even if it's wildly off, it's like the gameplay is going to be kept up to date with newer packets and things like that. Excuse me. The one thing that we have found that really helps is, so if you're like an experienced Dome Keeper player, you probably know how long you need to hit this type of monster with this level of laser for it to die. And if you start including like round trip time with packets, or you need the server to agree that this laser is hitting this monster, it's starting to feel really bad. And so one thing we are doing is letting clients report, hey, I'm hitting the monster and I just killed this monster. Because on my screen that the laser was hitting this monster for this long amount of time and now they're dead. But the only reason we can do that is those decisions we made up front, that we're going to trust the clients that they did the thing that they said they did. So again, it could be really easy for someone to make some sort of mod that says kill all monsters, and it's just going to kill every monster on the host, and that's fine if they want to do that. But we really want to give people that experience, because again, that dream that they have is, I want to play Dome Keeper at my ability, and I want to play with my friend. And so that was our way to make that happen for them. Leverage the multiplayer peer. So you want to write your game in an agnostic way that gives you so much more flexibility, especially if you have cross-play ambitions down the line, even just from Steam to Epic or things like that, even if you're just targeting PC. One thing I see happen all the time in the Godot Steam Discord is people integrate Steam into their game, but then now every time they want to test anything multiplayer, they have to have two computers, because Steam doesn't let you run two local accounts, or they have to get a friend to help them, or things like that. So if you write with a multiplayer peer in mind, you get Steam set up, you get it working once, but then you test locally with eNet, and so you can get everything working. If you're wanting to test things like latency and dropped packets, you can use something like Clumsy on Windows or Network Link Conditioner on Mac, and they can simulate all those different network conditions for you. Then you only need to beg your friends to help you test Steam at the end when you have everything working. And one thing to note is, as part of this process, we're actually working on an updated Steam multiplayer peer. So when we went through the process of doing the PlayFab multiplayer peer, we got really opinionated on how these should be built. And so we're going to do that, and that's going to be contributed back to Godot Steam this summer. Ordering is really hard, and so that's the big kind of motivation for doing that connection state, is that even when you do reliable ordered packets, games are hard, and the way things work, and you send some things reliable and some things unreliable, you can't actually rely that reliable packet got there first, and then this unreliable packet got there second. And so you end up in that stage where you're just going to see a lot of errors in your code. And it gets to the point where you just start ignoring errors in your code because you're getting so many packets coming in, and they're just errors about packets, and then you ignore real errors and things go badly. So one thing we like to do is use higher level nodes. Like rather than having each monster talk to each monster on each client, they all talk through a kind of higher level monsters node that has a dictionary of the UIDs of the monsters, and it gets packets in about each monster. If it has that monster, it'll act on it. If it doesn't, it'll store that packet and act on it when that monster finally comes in. And really one of my takeaways is never assume that you have all the data you need unless it all came together as one big RPC. So if this tile data came in, and then separately we got who the keepers are, and basically you have to write everything very defensively, or wait till you have everything ready on the server and send it all over as one big one big packet over if you can. But if you take one thing away from this talk, it is stay scrappy. So take advantage of that safe serialization. Like, it might feel bad to like lump up giant dictionaries of data, strings, and send it over the network. But you want to do that to get started. You don't want to be rewriting your whole game for this. It's probably never going to be worth that level of effort. Even for a game like Domekeeper, which has been very successful, it would not be worth rewriting the whole game. Pick a small number of systems and content and get back to playable as soon as humanly possible. So when we started, we actually had multiple keepers remotely mining an online gameplay in like less than a week, because we just focused on keeper position, hitting tiles, and being able to load into the game. And so we were able to just like really get going on that as fast as possible. It took another 3 months just to get like the whole game loop complete, but we were able to play the game and get back into the game really quickly. Let the small stuff stay out of sync until you need it. There's actually still things that aren't networked. We're still working on the project, but things like weather and things like what your pet is doing, and it just doesn't matter for the playtest. So it's going to be the last thing that we do. So when you're doing this as well, like again, you're going to see a lot of things that look out of sync. But if it's not affecting gameplay, just ignore it until you're done. And then once you solve its core issues and you have that like a small subset of your content networked, then start going and going wide, adding all those additional things. I want to say thank you to the team at Bits for letting us join them on this awesome journey for this awesome game. If you haven't, you should check out Domekeeper on Steam. Version 5.0 will be coming out soon. We're really excited to get that going in your hands. So thank you. I think there's a microphone set up over there, if that will be easier, if people want to stand up, or someone can walk the microphone around today.
Oh, for getting questions audible out of the screen.
Hi. All set? Hey, thanks so much for the presentation. You mentioned that that Domekeeper is going to support local and networked play.
Yeah.
So I'm wondering what local clients look like relevant to multiplayer clients. Like, are you relying on local information, or are you also treating it as if you have to sync to them or something?
Yeah, no, that's a good question. Local clients are purely local, so there's only one EXE running. And so the hardest part about local has actually been viewports, of like actually splitting the viewport when you have people moving around and things like that. That continues to be a nightmare for us, actually. But yeah, generally we adapted the systems to accept like when you interact with something, which keeper actually hit that and things like that.
So then if a second player is local,
Yeah.
on the network host,
Yeah.
then that second player is also
technically
RPC'd
the host.
and
Yeah,
synced
the players themselves. So you have clients and then you have players. And so the client, you have the host client, but that host client might have multiple players.
Gotcha.
And so yeah.
Okay, cool.
Yeah.
Thank you.
Yeah, welcome.
Hello. In my game, I have basically each player sends just their inputs to the host.
Yeah.
And I was wondering, it's basically a dictionary full of Booleans.
Yeah.
So I was wondering, do you have any resources on how to do like a bit flags operations and all that stuff? Because it seems super confusing.
Yeah, Gaffer on Games is like the Bible for network code, and he goes through everything from state synchronization to state compression to getting down to that level of kind of bit packing and things like that. So.
All right, thank you.
You're welcome.
What was the name?
Gaffer on Games. Yeah.
Thanks a lot for the great talk. I'm curious, did you have any systems implemented to test latency?
To test latency, so yeah, it's actually built in a little bit. So most of the team at Bits is in Germany, and so when we do play tests with them, we do some real life latency. We actually that play test that I showed the video of, it was like someone's like old laptop in Germany as we all played from all over the world. But so things like clumsy and network link conditioner you can built in to add latency even over the local network. And then we do a lot of different interpolation between those physics packets that come in for like a keeper position, like the air mite interpolation and things like that. So you can actually smoothly move along. Yeah.
I'm curious, was there a certain latency threshold you were targeting, like say 100 milliseconds, and then you thought that would be sufficient or anything like that?
Well, latency is not something we can control, and so yeah, it's kind of it's hard to when you test it locally. It looks like you're like, oh my gosh, this is so terrible. But like when you're actually playing online, you only see your screen. You don't actually see what's happening. So the biggest thing for us is systems where I'm creating local input and I'm having to wait for that round trip to come back. So when you're like carrying different resources and you're moving around, that starts to feel really bad around 200 milliseconds, but it's just nothing we can do about it. Yeah.
Awesome, thank you.
Uh-huh.
Yeah, I just wanted to ask specifically about the packed byte stream.
Yeah.
I know that you were saying you were going to do a push for the Godot Steam changes that you were
Yeah.
opinionated about.
Yes.
But I was wondering, is the packed byte stream going to be included in that, or do you happen to have a GitHub for that, or is that just something that's like, I mean, it didn't seem that complicated
Yeah.
to do, but.
No, it's not too bad. It's just a lot of math, but I think it could be interesting that you have to move that to C++ and whatever. I hadn't thought about that, but I will now.
I appreciate it.
Yeah.
Good talk.
Thank you.
Hi. So you mentioned the idea that you're okay with if a player creates a mod that just cheats essentially.
Sure.
So you've obviously had some thought about like how you do mods over multiplayer. I'm curious to hear a little bit more about your strategy about that.
Yeah, so there will be basically a handshake process when you're connecting that basically you're going to talk about what mods you have installed. And I believe the end result is just going to be, it has to be exactly the same. So everyone's reporting the same mods, the same versions, or the connection won't happen. So
Okay, so you're going to use something like a hashing system with which mods are installed?
yeah, or honestly, just send the giant dictionary back and forth and just make sure it's the same. Yeah.
All right, cool. Thank you.
Yeah, you're welcome.
So I had a couple questions about those like higher level like network handling nodes you were saying. Like you had one for monsters and one for
Yeah.
for players. So how did you decide how to split that up? Or I guess like why not just have one giant network handler, or if was it just like for sanity of development? Or?
It's a good question. I think you could have gotten away with any of them, but I prefer when I'm like creating systems to have one thing handle one thing well. And so like being able, like we know based on your connection state that you will have a monsters node available if you're in the sync state. And so that I just want to like, at that point then I can create these components that are more kind of like self-contained and monsters just know about their monsters and drops know about their drops and things like that.
And then
So
are those things just like singletons that float around?
they're not singletons, no, they're actually just part of the game world. And so
Okay, so each scene would have
each
like
scene would have its own. So if you're in the loadout scene, it has its drops, you know, and the level stage will have its drops and things like that.
And so would each of do each of those have their own kind of state, or are they pretty much stateless and just like forward network calls to?
They keep
to
a
where
state. They'll keep enough state to know about the individual drops, but that's about it. Yeah, they're mostly forwarding it down to the specific nodes. Yeah.
And then just one more thing.
Sure.
So Dome Keepers is very single player, and so I would imagine the clients aren't totally dumb clients anymore, or like with this.
No, yeah, most of the game is still happening locally on each client. Yeah, we're just sending just enough that what it comes up with should be the same. Yeah.
Okay. Okay. Cool. Thank you.
Yeah.
Just a quick question about the bytepacking and bitpacking for the packet.
Yeah.
Afterwards, have you considered doing any kind of like fast compression on them? And if you did, how bad is it? If you didn't,
Yeah.
would you consider it?
It's a good question. I think to really take advantage of that, we would have to, for any sort of compression, I think it would have to have similar data. So it would have to be, I'm trying to think if we would be a good candidate for that. But
Because I was thinking that since you're already bitpacking, the data itself
probably
is like,
kind of random, kind
Yeah.
of garbage anyways. Yeah, so I don't know that we'd see much there, but it's definitely something worth investigating. I do believe that when you send RPCs, the Godot itself will try and compress some of that packet down, but I'm not sure if that's always the case with packed byte arrays or not.
Yeah, I'll be curious to know how.
Yeah.
I think this is a dumb question, so bear with me. But when you're doing peer-to-peer multiplayer like this, you still need a server somewhere to connect the peers together, right? Or
Nope. So the host is the server,
Right.
so like an eNet, and then everyone will be talking to the host. So when if eNet, the reason that we just call that LAN is because there's no way to kind of, in a lot of cases, escape your router and talk to the internet over to this other person without opening ports. And so things like Steam and PlayFab, what they do is they have relay servers that will send the packets to them and back, and if they can open a direct path between those clients, they'll do so, and in which case there's no servers involved.
right, but there still are relay servers, and so your recommendations for using relay servers are either Steam, PlayFab, or
Don't run your own. I
Okay.
mean, you can, but why?
sure. But PlayFab is just like is PlayFab cross-platform?
Microsoft's cross-platform kind of, they have everything from like leaderboards and things like that, but PlayFab Party itself is, yeah, you can connect and create lobbies and then create, those relay servers between clients, so.
Cool. Thank you.
Great talk, by the way.
Thank you.
You mentioned that part of your planning process for adding multiplayer involves trying to figure out how the game will be balanced around it.
Yeah.
I was wondering if you could speak a little more to that. Do you have any rules of thumb about do you trend towards less difficulty with adding players, or do you have kind of cleverer ways to fine tune the difficulty?
That's a good question. I will say a lot of that I defer back to Bip and Bits for, since they're the kind of maintainers of the game feel. But my instinct is that a game like this has its own built-in inherent scaling with challenge. So actually bringing a friend sometimes makes things harder. For instance, again, who's in the dome? Because we're probably going to increase the number of monsters, but then you probably both have to be in the dome. You can't actually split. But even just now we both need resources because we're both trying to upgrade our keeper. So we're actually competing against each other for resources. But generally, I think it's just more of a game feel. You just have to really play test it and see. Because I think we were shocked about how hard it was. Given we thought we have 7 of us and we're all experts at this game. What could go wrong? And a lot went wrong. So, yeah.
Thank you.
Uh-huh.
Hi again. So I remember in one of the Domekeeper devlogs, they discussed converting from Godot 3 to 4, and
Yep.
one of the reasons was for multiplayer.
Yes.
So can you speak to why that was necessary?
Yeah, it's actually, it might have been part of, when I first met them and they were selling Godot 3, they were in the process of moving to Godot 4. There's a lot of reasons that you would want to be on Godot 4 for multiplayer, and it's all just quality of life. We're actually not using, since we're not really using multiplayer spawner or synchronizer in this final version, we technically could have done this on Godot 3, but getting started with the spawner and synchronizer just gave us so much immediate feedback, and again, we were able to get people moving and mining and things like that within a week, and that was all with the spawner and synchronizer nodes. But even then, we have, with Godot 4, you can actually launch multiple instances that all attach to the debugger. And so when you're trying to figure out oh, did this bug happen on the server or the client, or you just want to inspect that local state, you actually have both instances attached to the debugger. And then even with Godot 3, you can actually specify separate run arguments for each instance that it launched. So you can have one automatically be the server, one automatically be the host. Again, so when you're just trying to fix something, you don't want to have to hit F5 and then, okay, you're hosting and then you're joining and then now we're moving into the game. Anything you can automate to get into that situation to help you debug it faster. So,
Cool. Thank you.
uh-huh.
So excellent talk. My question is about, you wrote your own interpolator kind of synchronizer system. For someone who doesn't have the knowledge or the ability to do that, I've been messing with NetFox.
Yeah.
Would you recommend something like that to do some of that interpolation, or should I look into doing my own synchronization
No, I
without
think
multiplayer spawner?
NetFox is a fantastic solution. It's kind of one of the things I would say my advice for converting a existing game versus creating a new game, because converting an existing game, our goal was to not touch all 62,000 lines of code. So restructuring certain scenes and whole systems was kind of beyond what we wanted to do. We had to do it a couple times, but it was not what we wanted to do. But something like NetFox, it has a built-in interpolation. It's got, I think it even has built-in rollback and everything like that. If you can do something like that and then make it work for your game systems, it's perfect. Yeah.
And then the other question was, my game also has that same thing of like the map. The first problem I ran into with NetFox and multiplayer spawner was that exact problem of when you load into the level and things aren't ready, multiplayer spawner starts sending stuff and errors out a bunch.
Yeah.
Your recommendation is essentially, potentially keep the state back, wait for the person to have loaded into the level,
Yep.
and then start sending, okay, here's your state, here's the things you need to spawn, and kind of avoid multiplayer spawner in those cases.
I think so, yeah. And unless you have it, like I actually still use a multiplayer spawner in Drift because it's kind of that perfect case of like I can just let you load into the game world and then connect to the client and let spawner just spam it with all the things that it needs. But when you have more of like a run-based game, like Dome Keeper, where you're in the loadout, you go to a game, you want to come back, you go back to the game. Spawner's not really a good fit for that. So
Thanks.
yeah, you're welcome. Awesome. Thank you guys.